All right. Well, welcome everybody to today's webinar. Uh, today's webinar is on powering up your M&A and strategy with advanced simulation and optimization. Just the first few key things to understand is that the actual documentation for this PowerPoint slide is available. There's also a downloadable version available as well. And just keep this in mind that we are going to be able to go through some demos today. So I'm pretty excited about today and pretty excited for you all to be here. So thank you and welcome.
All right, so welcome everyone. Let me introduce the presenters. Today we have with us Alex Franco, he's the director of supply chain here at Sinwell. He's a seasoned experience in supply chain. He's helped some of the top brands to solve their supply chain challenges. And myself, Isidro Liñán, I'm supply chain practice lead at Sinwell, and I coach consultants here at Sinwell to use in logistics and to solve business challenges. This webinar is hosted by Any Logistics, a powerful tool for solving supply chain models, and by Sinwell. So let's get started with the webinar. Okay, so today we're talking about mergers and acquisition. As you know, merger and acquisitions presents both opportunities and challenges for supply chain executives. Supply chain executives are tasked with optimizing previously disconnected organizations while keeping business running. So something that we wanted to share is that according to research, those mergers and acquisitions are usually based on capturing synergies, and around 50% of the expected synergies are in the supply chain. If you see here in the last bar, for B2B and B2C products, for manufacturing and retailers industries, the synergies that are in the supply chain could be 50 to 60% of it. Capturing these synergies is not an easy task. And working with our customers, we have identified some of the main challenges that our customers have to overcome. The first one is that they need to crystallize the ideas by identifying and planning how to create deal-related synergies. The second challenge that they have to overcome is to get buy-in from the stakeholders. That means that they have to gain their trust and generate momentum. And then finally, they need to develop a capability to change and show changes on the fly. They cannot prove things in the real world, but they have to learn how to rely in powerful simulations to show all kind of what if scenarios. Okay, so according to those challenges and working with our customers, what we have identified is 3 critical success enablers that we are hoping to show you how we connect these ones to using a tool like Any Logistics. The first one is rapid prototyping. The days of having multiple months, waiting for multiple months and still see results from a model are gone. And now all the companies and the stakeholders demand that they see results as soon as possible. So representing the networks efficiently and identifying the potential value and how to capture it is a critical enabler for being successful with mergers and acquisition and capturing the synergies. The second one is transparency. No one wants a black box anymore. So models needs to be transparent and easily explainable to all stakeholders. And last, models needs to be really powerful to support multiple what if, and as well include the variability of multiple dimensions like demand, prices, and everything that could impact the opportunities. Okay, so having said that, let's go into the demo. Let me bring here our tool. This is Any Logistics. For those of you that are familiar with Any Logistics and those that are not familiar with Any Logistics is a simulation tool that is ideal for simulating your supply chain challenges. So today, we're gonna do a case with mergers and acquisition in which we have 2 companies that produce and sell shoes, and they are the blue company which has customers all across the US. So you can see that it has multiple customers here, and you can see the dots here in the map. And they have multiple distribution centers to serve these customers. This company has a revenue approximately of $100 million. And then we have the red company, which is slightly smaller. It has a revenue around $50 million per year. They have customers all across the US, and they have different locations for distribution centers. They have a different strategy for serving their customers. As you can see here, logistics enables us to see really intuitively how are these customers and the distribution center connected. In this case, this is usually the starting point of a merger and acquisition in which two companies are completely disconnected, right? So only the blue company can serve only the blue customers, and the red company can only serve the red customers. So let's say a little more, let's take a look more here about how are they connected. So now that we know the locations, then the next thing to look at is that with a tool like in logistics, we can quickly know what is the cost of transportation, because we have templatized tables here. This is the cost per kilo per kilometer travel. And then something really important that is really in high demand now with our clients is that we have an intuitive way to input the CO2 calculations. So using a CO2 parameter, we can really quickly add it to the model, and then we'll have CO2 results. Apart from the transportation costs, we have another important cost, which are the facility expenses that you can see here. And here, the blue and red company have a different cost structure in which the cost per day per warehouse in the blue company is higher than the red company. Finally, we have the demand. And here we can see that each customer has their own demand. And one of the best features about the logistics is that we can actually use all kind of distributions for our demand, that we are going to see how this is really important in the last part of this webinar when we play simulations. Okay, so let's run our network optimization. What we're trying to do here is to see what will be the normal operations of these companies if they were disconnected, if each of them will serve each own market. So we can see here, we can see the results. Okay, so we can see here, sorry, close this one, and let me close this one, let me make this a little bigger. We can see here that we have what distribution center serves each of the customers, and we can confirm here that only the blue ones serve the blue customers, and the red, this is serve the red customers. And here we can see the results, right? So the total number of SKUs sold in a year by both companies was 1.6 million, and the total profit was 74 million. And if we go here to the objective members, we can quickly see what was the CO2 emission. So we have a really intuitive way to capture the CO2 emissions. We can see what has been the facility cost, and then we can see what is the transportation cost. All right, so this is what we call rapid prototyping, because really quickly and intuitively, we have a baseline build to know what is a starting point with those two companies that are not connected. Okay, so now, as we conducted our merger and acquisition, the expectations is that we are able to evaluate what will be possible if we merge the operations. And now all the warehouses, so either the blue and the red, can serve all the customers. Okay, so you can see here, and there you go, that in this model, everything is going to be connected. We're going to run the network optimization, and then we're going to see the results, in which the network optimization is going to identify what is the right number of distribution centers and what is the right flows to serve our customers. Okay, so we have our results here. And one of the really good features of in logistics is that we can have not only one solution, but we can have multiple solutions. In this case, we've asked the network optimization to provide us with 10 different solutions in which are different strategies that we can deploy our disease, and we can see really quickly here what is the differential in profit. Okay, so our preferred solution here will be solution 1, in which we have only these warehouses, serving the whole US, right? And talking about transparency, one of the advantages that we have here is that now, since we have 10 different solutions, we can go to the objective members and we can filter and compare different scenarios. For example, if we do profit, okay, if we see in CO2s, we see in the profit at the beginning, but we can order the solutions by CO2, right? So if we're interested in knowing what is the option with the lowest CO2 emissions, we know that the option number 4 will be the lowest one. Okay, so you have the solution here, right? These are how are disconnected. And then let me show you that's a little summary here. That I have a table here that summarizes this one, right? So we talk about the pre-merge. This is the solution that we had, in which we have 9 DCs. And then we have the revenue, which is the same, and the transportation cost and the warehousing cost. So when we merge our companies, the best solution, so solution number 1, will be to reduce the number of distribution centers from 9 to 4, 1, 2, 3, 4, and this is the number of distribution centers that we have. And then if we're interested in minimizing CO2s, at least an option that we can explore is, instead of using solution number 1, is deploying our distribution centers 1, 2, 3, 4, 5. You see it here. And you will be able to quickly compare all the elements of transportation costs, warehousing costs, and CO2 emissions. Okay. All right. I see a question, how are the multiple solutions run? And I can show it again. Okay, so the multiple solutions run is simply, if we go here, we run it. Sorry, let me show you the parameter for that. We can select how many solutions we want to find. So in this case, we want to find 10. So we set this parameter up, and then we click on running. In a few seconds, okay, we have all our solutions. Yeah, that clear? All right, pretty good. So let me see now. Okay, so we merged the companies, and then we have a good idea of what is possible if we use the nodes that we already have in the network. The usual question that we have then is like, well, what if we were be able to consider other locations that we don't have in our network already? And then we do that utilizing a greenfield analysis. And we're going to move and show how we do this in logistics. Okay. Jonathan, I see a question that says, what changed between solutions, right? So what changed between solutions is the DCs that are open or closed, and then what customers are served from which of the DCs, right? So if I go to the different scenarios here, you're gonna see like the DCs, the location change, and then they are served, the customers are served from different locations, right? Thank you. Let's see. Okay, so let's move on to greenfield analysis. Okay. So in the greenfield analysis, here, we have the same customers that we saw before. We have the blue customers and the red customers. And then we are going to run a greenfield analysis experiment that's going to find us good potential locations that we didn't consider before in the map, right? And what it's trying to do is minimizing the distance, the weighted average distance to the volume that is ordered by our customers. So we're gonna run it like this. Okay. And in this case, we can start looking for a solution that gives us 4 DCs, right? And then we can see here the solution. And the advantage of this analysis is that we can really quickly compare and see, okay, so we run a solution with 4, what will be with 5? So we just change the parameter, and then we can see the solution with 5. We want to see it with 6. We just come here and change it to 6, and then we will see the solution with 6. So as you can see, we can find really quickly different options. Okay, yeah. And then we know what changed between scenarios looking at the product flows. Here we have a table in which we can explore the different warehouses. Okay, so first, in the results, we have the new locations here in this table, right? So if we move through the different results, we'll be able to find the new site locations. And then the second part is that we're going to go to the product flows, and we can filter into what warehouse serve what customer and what quantities. The changes by looking at the results. Okay. All right. Perfect. So the advantage, as we said, is that we can run really quickly 4, 5, 6 different resources, different disease views. And what we usually do is that when we are done running our scenarios, we can create visualizations like this really quickly, in which we can compare all the different scenarios, and then we can create lines like this, which are usually really powerful with customers, in which we have 2 axes showing what is the mile distance from the warehouse to the customer. And here on the vertical axis is what is the percentage demand covered by that line, right? So for example, here, the blue line means that with 1 DC, we only cover 30% of the demand within 400 miles, right? While with 2 DCs, it goes up dramatically, right? Within the first 400 miles, we cover 80%. And the point of this visualization is to find what is the break even, or what is the where does it taper, where doesn't make that much sense to keep adding warehouses, because we are not gaining on reducing the average to the customers. Okay, let's go back. So these once we have our results here, and we said that 4 look like an optimal solution, like 4. All right. The advantage is that now we can move these locations to our network optimization and start using the facility cost and the transportation cost and compare with other solutions. So let's do that. Okay. So we moved our, okay. So now, as you can see, we have our DCs moved here to our model. So in addition to the 9 warehouses that we had before, now we can see 4 more warehouses. And now, as usually happens, right, when we have new changes, there are usually new requests from our stakeholders. So we need to update we need to update the assumptions and the parameters. So in this case, our stakeholders ask us that for running this scenario, we're going to consider different cost structure for our new DCs, DFA DCs, and for the transportation cost. So those parameters can be quickly updated in the tables that we have here allowed, right? So while before we were considering the cost per day per facility for the blue and the red DCs to be 21 and 13,000. Here we have received information that we can get new warehouses which have fixed cost of $12,000 per day. And then we have received information as well that for these new warehouses, we're going to be able to reduce the transportation cost, and it's going to be reduced from 0.05 per kilo per kilometer to 0.03 per kilo per kilometer. So combining all the requests from our stakeholders, now we're able to solve and to show the results for this updated scenario. Okay, so let's do it. We go here. Okay, and again, we are running 10 different solutions. And our first solution reaches a profit of $131 million. And we can see that it selects to use the DCs in this way. Okay, split in the US. And really quickly, we want to compare it here, right? So merging with GFA locations, including the changes that our stakeholders had asked us, which is reduce the transportation and warehouse rates, we find that the transportation costs go down to $15 million. The warehousing costs go down to 17 million, and the profit is increased to $131 million. And the new CO2 emission is 226 million grams. And you can see here that new solutions, we have the nodes, we have the connections. So we have everything that we can show to our stakeholders, provide, receive more feedback, and then keep delivering value with this rapid prototyping, showing them what will be the changes if something is requested. Okay. 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 So Jonathan, I think my colleague Alex Franco is taking notes of the questions, and then we are gonna tackle them at the end of the webinar. Okay. All right. So let me just go really quickly into the most interesting part and the thing that gets us more excited, which is the simulations, right? One of the main advantages of any logistics is that it's a solution which is leader in simulation. And we want to show you a little tease about how we can leverage what ifs and simulations really intuitively with any logistics. Okay, so a really quick scenario here that we can do is that if we receive, for example, some feedback from our stakeholders and they tell us, you know what, the solution with 4 DCs is good, the ones that we see here, but we really want to know what will happen if we close the warehouse on the west, which is this one here, Phoenix, and then we serve these 2, Portland and Seattle, which are really far away from Chicago. So then we can go to our tool, and then we can go to our path, and then create the new path that will represent the air freight from Chicago to the customers on the northwest, and then we can run it, and we will see the results. Right? So really quickly, when we get a demand from our stakeholders, we can model it, we can run it, and we can see the results. Right? So for example, this one here, we can see what changed, right? And whatever request our stakeholders want, we can solve it and say, well, that idea, what it's going to cost is that our transportation costs are going to go up to $47 million. We're going to save on warehousing, right? But the CO2s are really going to go up because as we have a higher CO2 emission with air, this is what it's going to cost. So they can be informed. All right. And finally, most exciting part, wanted to show you the simulation. Okay, so if you follow the presentation, you'll notice that for our new DCs, we consider lower rates, right? Transportation rates. And it's fair to say, well, transportation rates can change. So why don't you tell me a range of what happens in the transportation change? So that's exactly what we can do with simulation. And simulation has really 2 powerful advantages. The first one is that now the demand You see the demand. We can consider stochastic demand, and that's really powerful because instead of considering just one number that is deterministic, now we can use all kind of distributions, and when we run our models, it will consider this variation, right? So every day, the demand of the customers, for example, for this one for New York could be 0, 16,000 or 13,000. So that we're going to recover, we're going to gather that information now from the model. We're going to run different multiple iterations and aggregating as show the mean and the standard deviation. So two important things for simulation. We can consider the variation of the demand or any other parameter, and then we can do variation experiments, which is related to the rate. We're going to set a variation experiment in which, as we said that the transportation costs were modified, we're going to show our stakeholders what is the range of outcomes if we consider the transportation costs from 002 to 008 in increments of 001. Let's run it. And it will take a second. Let's encourage you, hoping that you enjoyed this webinar. We try to be really quick and to the point in this webinar. If you want more information, you can always download in logistics going to the website. We have the PDF of the presentation in this webinar as well. So if you download it, you can click on the links or you can scan it. You can find new webinars in logistics and upcoming events. And you can visit singwell.io to find how you can start capturing your M&A synergies and much more. Okay, there you go. So we have this one. Alex, any other questions? Something that we should consider?
All right. So, Cedar, we do have a few questions. I know we have a minute or two. So I'm just going to go over quite a few of them that were asked during the webinar.
Yeah. Alex, if you give me just 10 seconds, right, I'll show the results here, right?
Yeah.
So you see here that this is really powerful, right? This is something that would have taken days to do with Excel or other tools, but here we can see like what is the result of the ranges, right, for different transportation costs as they go up, and we have multiple statistics here. So we have the profit, and each of these lines have been run multiple times and considers the variation of the demand. So we have the profit, we have the demand served, the CO2, everything is summarized here, and then we can go into more details if we had more time.
Yeah, perfect. So we're almost run out of time, but maybe we have one question we could answer. So one of the questions is, how can somebody quickly compare different types of iterations or variations of simulations? What's a good component potentially or experiment to use here?
Mm-hmm. Yeah, so in this case, what we usually do with customers is the transportation costs, because as we know, those transportation costs go up and down. So that's something that's really interesting for customers. And then the demand as well, right? So we have two folds. We can capture the demand feeding when we feed the demand and we understand the usual demand. And then we can do variations as well, doing increases of demand, right? So it could be like, what if it's 10, 20, 30% extra?
Perfect. And just to add a little bit, there's also a comparison experiment that can be used to leverage deltas between some of these different scenarios. All right. I think we got one more time. Someone asked about the number of GFA solutions, the number of customers they could potentially do, and how many they can do. Is there like a limitation to that when we're running models?
No, so there is no limitation. We usually advise to model wisely, right? So start small always, and then keep adding elements to the model as they are needed, right? So a best practice usually is aggregate at the zip code when you have thousands of customers, right? So there are always ways in which you find the right balance between modeling and detail.
Okay. All right. Well, it is the end of our 30-minute session. We've gone a few minutes over, so we really appreciate everyone for joining today's webinar. We're definitely here to help. So if you have any questions, feel free to reach out to any logistics/Simwell, and we can definitely discuss any business challenges, any circumstances, or definitely technology you want to include into your own organization. We'll see you on the next webinar. Thank you for joining. Goodbye.
Thank you so much.